First question is, what does the CRISP DM methodology for data mining entail? What does the data analyst do in each step? CRISP DM is a widely used methodology for guiding data mining and analytics projects. It entails communication, collaboration, and critical thinking skills to advance projects and ensure effective results. In the first step, which is business understanding, the analyst works with stakeholders to gather what the objectives and expectations are of the project. The second step, data understanding, the analyst collects the data that pertains to the topic and identifies what is usable for the project, both in terms of data quality and relevancy. Third, data preparation. The analyst cleans and transforms the data. In this step, the analyst dives deep into the data and identifies patterns and areas where it is most interesting. Fourth, modeling. The analyst uses different algorithms and parameters to see which techniques best addresses the problem. Fifth, evaluation, is when the model is sent out to a validation team for testing and feedback. Here, the analyst checks the results and determines if any changes need to be made, if the model needs to be thrown out, or if it can be deployed. And sixth is deployment. Is after the model has been accepted, the analyst sends the model to the relevant team to implement and provides monitoring and maintenance while the model is in use. The second question is, explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? The first step in time series analysis is always a basic data quality check for irregularities in the data. This analysis also requires for the data to be formatted in a stationary way, which means that its statistical properties, for example, the mean and the variance, etc., they don't change over time. They have to remain constant. After the data has been checked, an appropriate model needs to be applied depending on the problem. Models that place different weights in value to more recent data may be preferable in some scenarios. The analyst must identify, train, and maintain that model that best predicts the effect on a variable. The third question is, discuss the main principles of data ethics, as well as what companies or organizations could do to uphold these principles. The main principle of data ethics are privacy, transparency, accountability, equality. First, compliance with laws regarding people's data is essential. Companies and organizations have a responsibility to adhere to those laws always. In order to make that more feasible, we need to know what information is being collected about us and who it is shared with. Securing the data and having proper safeguards against breaches in security is necessary when handling private information as well. If something goes wrong, we need to know how it went wrong and what was done about it in a timely manner. And finally, equality. Data can be a dangerous weapon. Organizations must not discriminate or allow bias into their data handling. Ultimately, organizations need to be clear and intentional with the information they gather and make sure that it is communicated to all of our stakeholders. Organizations are also expected to hold themselves accountable whenever breaches occur. The fourth question is, imagine you're an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with your manager? Make some suggestions for how to avoid measurement bias in the future. Simple. In a situation where I have concerns about measurement bias on a project, I would be sure to have all of my facts straight. First, I would identify the source of measurement and the characteristics about it, as well as the assumptions it may have. I would then state my concern to the manager and the rest of the team and why I believe it is relevant, and allow the manager to decide how to proceed. To avoid measurement bias in the future, we can have multiple sources of measurement and then compare the results. Another way is to require a certain level of expertise from validators. The fifth and last question is, explain the difference between regression and classification models in predictive analysis. When would you use one of these models over the other? Classification models are applied when dealing with the dependent variable that is binary. Modeled with a decision tree, they reduce comparisons to true-false statements that, when analyzed, produce a probability score between 0 and 1, which is the likelihood of this event occurring. This is in contrast to regression models, which use continuous dependent variables that produce a line on a graph. Classification models can be used in spam detection and medical diagnosis. Regression models can be used in looking at price relationships, temperature and atmospheric carbon dioxide levels, and anywhere else you are comparing two numerical values. Thank you.